So for this project, we've started by creating a small test app that will load the calibration images and calibrate the cameras using OpenCV. So we've got the code for that here. So go ahead and run it. It loads in each calibration image, shows you the checkerboard for where they are. We ended up only actually loading 12 of the, or sorry, 24, 12 right and left pairs for the calibration, just to make it go quickly at the moment. And then it computes the stereo calibration and rectification images. And then we load in a couple sample images just to start doing that. So the next step is implementing our own rectification and 3D triangulation. You can see here we have all the camera matrices, and distortion, and the rotation and translation between the cameras. Then we also I've been working on doing clustering and segmentation. So we're implementing an algorithm that starts by doing skin detection, and it identifies regions of skin in the images, and then from that it uses each skin cluster and slowly builds out the point cloud starting at that skin cluster to find a human. So we've got the framework here to do that as well. It does a lot of different filtering and heuristics to try to figure out which cluster had the skin region that started as the head, and then from that we match a bunch of human body poses to the point cloud and try to figure out the human pose.
We have also worked on implementing a kinematic chain, which is essential for representing the human model. The kinematic chain as it stands right now is a bunch of joints which are connected to each other by a translation. Each joint has its own rotation, which its children inherit. In the current code we have 100 bones or links or chains connected to each other, each offset by a constant rotation from each other. At this point, this is just for testing purposes to make sure that we're getting a reasonable result. When we go ahead and run the code, it prints out its output in a form that MATLAB can understand, which we did to make it easier to validate these results and determine whether or not we are getting the results we're actually hoping to get. It takes a decent amount of time for it to run because we are doing no memoization or anything intelligent with the input and are instead recalculating the entire chain whenever we need to access a single element. When we bring this data into MATLAB and plot it, we see that we get a circle as we are expecting, which means that the rotations are working the way that they should. From here, we need to expand this to work with not just a single kinematic chain, but a kinematic tree, as the human has some places, like the shoulders, where multiple joints are connected to a single joint.